So today, we're going to crack open the Builder's Toolkit. Nope, not the one with hammers and saws, but the one with the very heart of construction, the materials themselves. And trust me, mastering these is the key to understanding how our world is built, right from the ground up.
I mean, really think about it. The home you're in right now, the bridges you cross, it all comes down to a handful of really foundational materials. In this explainer, we're going to dive deep into 5 of them. The humble but mighty brick, the incredible binding power of cement, the timeless strength of stone, the amazing versatility of timber, and yeah, the essential finishing touches that pull it all together.
Okay, let's start with the very first tool in our kit, the foundational brick. It's one of the oldest, most trusted building materials known to humankind. It's an absolute classic for a very, very good reason.
But you know, making a good brick isn't as simple as just baking some mud. It's a science. It's got a very specific recipe. The main ingredient is alumina. Think of it as the glue that gives the clay plasticity so you can actually mold it. Then you've got silica, which is basically the brick's skeleton. It stops it from cracking and warping in the intense heat of the kiln. And of course, lime and iron oxide. They play their parts too, preventing shrinkage and giving us that iconic red color we all know.
So, knowing the ingredients is one thing. But here's the deal. Not all bricks are created equal. For any project where quality is everything, you absolutely have to know the difference between just an average brick and a first-class brick. So how can you tell? Well, the good news is you don't need some fancy lab for the first few checks. A first-class brick, it should be perfectly uniform, with sharp, square edges. And here's the really cool part. When you strike 2 of them together, you shouldn't hear a dull thud. No way. You should hear a clear, almost metallic ringing sound. That crisp sound tells you it's dense, it's strong, and it has been fired perfectly. All right, now for a number that is absolutely vital to remember. We're talking about water absorption. So after you soak a brick for 24 hours, a top quality one should absorb less than 20% of its own weight in water. This is a huge indicator of its durability and whether it can stand up to the weather over time. And here it is, the second non-negotiable value, crushing strength. A first-class brick has to be able to withstand a minimum of 10.5 newtons per square millimeter of pressure before it even thinks about failing. So the bottom line is, a great brick has to be incredibly strong, and it can't be too thirsty. Next up in our toolkit, cement. If bricks are the building blocks, then you can think of cement as the powerful binding force, the superglue that holds absolutely everything together. And just like with bricks, its key properties, they're all defined by the numbers. First, let's talk about time. 30 minutes. That is the minimum initial setting time for ordinary cement. What does that mean? Well, it gives workers this crucial window to mix, transport, and place the concrete before it starts to get hard. Any less time and it would just be a frantic race against the clock. Next number, 10 hours. This is the maximum final setting time. By this point, the cement needs to have hardened enough to have its full structural integrity. This just makes sure that the chemical reaction isn't dragging on for too long, because that could actually compromise its final strength. And one more key number for you to lock away, 3.15. This is the typical specific gravity of cement. It's really just a measure of its density compared to water, but it's a fundamental property that's used in all kinds of concrete mix calculations. It's a simple number, but a really important one. Now, let's talk about a test that is all about long-term stability, the soundness test. This whole procedure is designed to check for excess uncombined lime in the cement. Why does that even matter? Well, because too much of it can cause the hardened concrete to slowly expand over months or even years, leading to these disastrous cracks. So this test, it's a critical quality control check to make sure the cement is going to last. All right, let's shift gears. We're going to move from manufactured materials to the oldest tools in the builder's kit, the ones taken straight from the earth, stones and rocks. And their properties? They're a direct result of their pretty epic geological history. To really get a feel for stone, you have to know where it came from. Geologists classify rocks into 3 main types, but don't just see this as a boring list, you gotta think of it as a cycle. It all starts with igneous rocks, which are literally born from cooled magma. Over thousands of years, these erode into sediments, which get compacted into layers to form sedimentary rock. And then when you subject either of those to incredible heat and pressure, they totally transform into metamorphic rocks. And knowing a rock's origin tells us exactly how to use it. Igneous rocks, like granite, are unbelievably dense and strong. That makes them perfect for massive projects like dams or building foundations. A metamorphic rock, like marble, on the other hand,
while it's prized for its stunning patterns and beauty, making it ideal for things like decorative flooring and facades. Basically, its function follows its formation. Let's move on to our next tool, timber. It's an amazing, renewable resource, but you can't just chop down a tree and start building with it. The secret to turning it into a really reliable material, well, it all lies in the preparation. That critical preparation process is called seasoning. It's all about the controlled drying of raw timber to get rid of its natural moisture, or sap. See, if you skip this step, the wood is going to twist, warp, and probably decay as it dries out unevenly. So the big question is, what's the ideal moisture content we're aiming for? Well, for most construction uses, you want your well-seasoned timber to have a final moisture content of around 10 to 12%. Hitting this sweet spot is exactly what makes the wood stable, strong, and way more resistant to decay and insect attacks. And what about an engineered wood like plywood? What's its deal? Well, its superpower comes from how it's made. By gluing these really thin layers of wood or veneers together, with the grain of each layer running at a right angle to the one below it, you basically engineer out all of wood's natural weak spots. What you get is a board with pretty much uniform strength in every direction. It's genius. Okay, so we've laid the foundation, we've built the structure. Now it's time for the final tools in the kit. These are the essential materials that finish the job, and they're just as vital for a project's success. First up is lime, and let's just quickly clear up the two main terms you'll hear. Quicklime is the raw product, calcium oxide. When you add water to it, this chemical reaction called slaking happens, and it transforms into slaked lime, which is calcium hydroxide. So really, you can just think of it as unreacted versus reacted. Simple as that. And now for a material that really defines the modern skyline: steel. Here is a number that is absolutely worth remembering. 7,850 kilograms per cubic meter. That is the density of steel. Its incredible strength-to-weight ratio is exactly why we can build the unbelievable towering structures we see all around us today. Whew, we have covered a ton of ground and a whole lot of numbers. So let's just do a super quick recap with a cheat sheet of the absolute must-remember values from our toolkit. Brick strength, greater than 10.5 newtons per millimeter. Cement's final set time, less than 10 hours. Seasoned timber moisture, right between 10 and 12%. And the density of steel, 7,850 kilograms per cubic meter. These numbers right here, they're the benchmarks of quality. And that brings us to the end of our tour through the Builder's Toolkit. We've looked at the tools, but knowing what they are is really only half the battle. So I'll leave you with this thought. You know the materials now, but how would you choose the right one for the job? That calculation of cost, strength, durability, and even looks, that's where the true mastery really begins.